Hi, Save. I'm joined with James Douma for another episode in a multi-part series unpacking the latest Tesla full self-driving progress updates. Some of them shared by Andrej Karpathy, Tesla's head of AI, in a recent conference talk. I'll link to the video description. The video in the video description. So in this video, I want to go ahead and dive into Tesla's supercomputer that they're using to train their neural nets and other tasks. And I want to get kind of James's take on exactly, is this supercomputer unique? Is it special? Can we deduce any type of, future plans for Tesla? And perhaps even what can we expect from Tesla AI Day, which might happen at the end of July, according to Elon Musk. So welcome again, James, to another episode in our marathon series. All right.
Here we are again.
There we are. So yeah, can we, okay, so let's take a zoom out first. In the bigger picture of full self-driving neural nets, all this stuff, like why does Tesla need a massive supercomputer? Like what's the main functionality? Is it, I mean, off the top of my head, it seems like first you have to train the neural nets based off of, this massive data set, which is like just in this, you have 1 million video clips, and this is not probably all of the data that Tesla has even, right, to train all of their multiple neural nets. So it's just, you have a massive amount and you need to train that. But also it seems like, are they using, you think, the supercomputer to do the auto labeling as well, where they're, basically constructing these 3D scenes based upon video clips and then back propagating them to the video clips? Is that a different kind of computer they're using? I'm just curious, a bunch of questions on this. I'm just curious to hear your thoughts.
Well, so the specs on the machine that they talked about, like this machine is appropriate to doing both of those processes. Okay. You could imagine a neural network. You could imagine, and perhaps Dojo will be, a training computer which is fairly specific to neural networks, right? I mean, there are architectures that you could build that would be really great at doing neural networks, but not so great at the auto labeling stuff, right? The auto labeling stuff is more kind of like generic 3D geometry stuff, whereas neural networks, you can narrow them down to a much smaller bin and optimize a lot more if you want to. Although it kind of sounds like from what they've said that Dojo is actually going to be doing the video thing also. So the computer that specs that they trotted out is, it's basically a cluster of NVIDIA's latest and greatest, highest performance GPU. And that GPU plus it, so these GPUs, they're in servers that have 8 GPUs in a server. And these GPUs are pretty big and they're pretty power hungry and they take a bunch of space. And so they have, they put 8 of these GPUs in a 4U rack unit with a server that has a couple of high-end CPUs in there. And so overall, the cluster ends up being a very flexible, very powerful number cruncher, especially when you combine it with all the software and all the libraries that are available for the NVIDIA devices. Like all of the neural network stuff that's out there runs on these GPUs, and it runs really well. They're highly optimized libraries for these GPUs for all the different kinds of steps of the process they might want to do. Like Tesla doesn't have to reinvent any of that stuff, right? All of the good frameworks are already optimized for this architecture. So it's a great architecture for doing, arguably it's the best architecture that you can commercially buy today for training neural networks. I don't think anybody would argue with that. There are specialized silicon architectures for training neural networks that various smaller startups have come out with. And they have their niche where they're really, really good. But generally, like if you're Tesla and you want to get a big computer and you want it to be flexible and you want it to be really fast and you want it to work tomorrow, you don't want to have a lot of bugs in the operating system, this is kind of unquestionably the system that you want to buy for doing that kind of stuff. So works for neural networks. But the other thing is, as we talked about in a previous video about how, like with the FSD chip is really optimized for running neural network inference. And it's not as good at doing lots of other things. Like one of the reasons that you might prefer a GPU over a neural network processor is if you want to do other things that aren't neural networks. So like in Tesla's FSD chip, And they've got a decent sized GPU in there, and they've also got a bunch of regular cores, because the neural network processor in there, it can't do everything they want. It can't even do all the parts of the neural network. It does the heavy lifting on the neural network, but there are these, bits and pieces that don't run very well on the NPU that you need done a different way. And some of those will run on the GPU. Like they have an RNN that they run, which is a certain kind of neural network that doesn't actually run as well on the NPU. And so they can run that part of the neural network on the GPU in that processor. Similarly, these A100 units, they have very good general purpose scientific libraries. They have very good graphics libraries. Like a lot of the thing that I was describing before about when you want to do auto labeling, one way you might want to do that, and perhaps the way Tesla is doing it, is where you essentially they're estimating the 3D scene, which you can do through straightforward geometric primitives, right? And if you were doing that, a GPU would be a great architecture for doing that on, because they're very optimized for doing that kind of graphics intensive, three-dimensional ray tracing, blah blah blah, sort of stuff that you want to do in those kinds of operations. So by going with a cluster of A100s, they're getting it's a system that's got great software. It's compatible with all the important frameworks. It's compatible with all the non-neural network stuff also that they might want to do. And it has a lot of HPC features. HPC are high performance computers. It's the term of art for supercomputers in the business, right? HPCs, an HPC isn't something that sits on one guy's desk and he uses it for writing video games. An HPC is a system that occupies a large building and which is used simultaneously by lots of people. So some of the features that you want in an HPC is the ability to dynamically partition it into different size pieces that different people can use, or the different tasks that you can use. So you can have multiple different teams working on different kinds of jobs, running different software, and they can all be using different parts of this big cluster simultaneously, because it's designed to be partitionable. Its fabric and its processors and all of its software allow for this partitioning that lets you use a single computer to do lots of different things. That lets you get your best bang for your buck, So my guess is this is about a $150 million machine. And so Tesla dropped a $150 million machine on it, and it'll be obsolete in 3 years, maybe 2, right? And they want to get their money's worth out of this machine over the next couple of years.
Interesting.
So I think it's great. If you'd asked me, I probably would have guessed something about like this. This is kind of a roll your own version. There's different ways that you can get a computer like this. Like at one end, you can go to NVIDIA and they make a DGX box, which is like the equivalent of one of these server racks. In fact, they make a DGX pod now that you can buy, which has a whole bunch of these DGX boxes where each box is a server, and inside each server, you have some number of GPUs and some number of CPUs, and that functions as a node. So you'll notice he mentions they have 720 nodes. So they've got 720 of these for you rack mount boxes that each has 8 GPUs in it. And this is NVIDIA's latest and greatest. It's the 80 gigabyte version of the A100, which has only been selling for a couple of months. In fact, I was actually kind of surprised that they got it, because I thought NVIDIA had been putting it in their own product, but I wasn't aware that they were shipping it to third parties yet. But anyway, so apparently Tesla managed to get them. These look like super micro servers. Like I went looking to try to figure out what server chassis it was, and I think I know that thing. And then the fabric is a Mellanox InfiniBand thing. And this is the closest thing to a off-the-rack supercomputer that you can get to. Tesla can buy the server. They can buy the A100 GPUs. They can get them from NVIDIA, or maybe Supermicro includes them as part of the bundle deal. The CPU part is a completely off-the-shelf rack. The racks are standard. The networking fabric is standard. And the way that you tie all this stuff together is all industry standard stuff. So it's pretty plug-in. It's like putting together a PC, but on a much bigger scale. Mm-hmm. And they have to buy the A100s from NVIDIA, and that's going to be expensive because it's single source. There's no other place that you can get that kind of stuff. And, NVIDIA doesn't have to cut you a deal on it. They can charge what they want. These boxes probably cost around $200,000 a piece, each one of these 4U rack things. And then most of the rest of the system is small compared to the cost of the fancy high-end NVIDIA GPUs. Mm-hmm. But it's a great architecture. It's the kind of thing that you can put together relatively quickly. Tesla, they don't have to write a ton of their own software to get this thing working. They'll have to write some, but there's a lot of off-the-shelf stuff that they can get going on it. And the numerical architecture is really well sorted for all the stuff that they want to do. And like, if they can, this is an appropriate benchmark to work against for Dojo right now, actually, because this is, if you're not designing your own computer, this is about as good as you can do for a reasonable amount of money today.
Mm-hmm. That brings up basically the question is, what is Dojo? So if this cluster, it's basically, I mean, pretty much or NVIDIA's, GPUs, high end, stitched together, it seems like. But, Elon has been touting Project Dojo for quite a while. I mean, what do you think is happening? Do you think they're building Project Dojo on like behind the scenes, meaning is it not yet operational? Do they even have a cluster? Is it just a small cluster they're working on? I mean, with Project Dojo, are we talking about their own, custom, you think neural net processing, chips that's going to be for neural nets, or is it going to be more multi-purpose like a GPU? Are they going to use NVIDIA, or are they going to do something else? Like, and then that's another thing is like Tesla recently, chose AMD with their infotainment. I don't even know about this stuff. Does AMD have anything to offer? I'm guessing Tesla chose NVIDIA for a reason, because they probably have the best, GPUs out there for this task.
AMD has really good silicon, but but the software support for the silicon is not great right now. I mean, NVIDIA is just like way ahead of AMD as far as software goes. So certainly you can buy a ton of AMD GPUs and you can build a big cluster, and the hardware will be cheaper than buying it from NVIDIA, but you will have to write a lot more of your own software to do that. And for most organizations that want to get something done this year, that's just not an option.
Mm-hmm. Got it. What do you envision Dojo to be? What kind of computer and what?
So my guess is Dojo's, they're doing their own silicon for the computation unit itself, that they want something that's closer. So, Google makes TPU clusters, right? Google has a neural network specific chip. The first generation was inference only. Google published a paper on that. And as a consequence, we know a lot about the architecture of that first generation TPU. So they've designed their fourth generation. Interestingly, they used a neural network to do the silicon placement for that. So like Google's actually using neural networks to design the chips that they're going to use for training neural networks now, which is kind of a cool thing. But so they've got the TPU-3 running in the data center, and their third generation TPU also trains neural networks, but it's a piece of silicon which is pretty much designed for training and doing inference on neural networks. But you can't buy it, right? If you want to use it, you have to, it's in a Google data center, and you can pay them for time on one of their machines, which lots of people do. It's a fine and economical way to train large neural networks. A lot of people do that stuff. But, you have to pay the Google tax if you want to do that. There's a premium for it. And if Tesla wants to control their own destiny, and if they want something faster than a TPU, like they might want something that is more specialized for the kinds of neural networks they're doing than TPUs. Because TPUs, it's a neural network that's not necessarily optimized for the kinds of neural networks that Tesla wants to do. I haven't looked closely at the architecture, so I don't want to make any strong statements about that. I'm conjecturing that Tesla could decide that they want something better. It could be that they just want to control their own destiny. It could be a cost savings thing, right? This is a fairly expensive cluster, and if Tesla is going up like 10x in clusters, for each generation in terms of the power that they want, which is like a reasonable kind of numerical goal to go to. Well, the next machine would be $1.5 billion. But if they bought a $1.5 billion machine, that would be displacing like $10 billion they would pay Google for compute time. I mean, you do get your money's worth if buying a supercomputer, if you keep it busy, right? It's a lot cheaper to buy and own it yourself than to rent from the cloud people, at least a factor of 3, and most of the time more than that. If you have really high utilization, you can have much more than multiple of 3 difference in the cost of operating it. But it also sounds like, from stuff that Elon has said, that Tesla is looking at doing much more aggressive things as far as the networking and thermals. So one of the big constraints on how fast you can make computers is how fast can you get the network, the interconnect between all the nodes, and how hot can you run a single node? Like, how fast can you run a node? And a lot of that comes down to just, how efficiently can you get power into it, and how effectively can you get heat out of it so that you don't melt it down, so you can keep it cool. And a lot of these, networking in part, but especially thermals, are they're kind of basic physics problems that are all about packaging. And they are the kind of thing which you could imagine Tesla or SpaceX people going at and being successful at. Most of the, these commercial solutions that are out there, they're designed to be like Legos. They're plug and play. They come in certain unit sizes, and they're designed to satisfy a large variety of people's needs. And so Tesla could look at this and say, hey, this is our, if we stay on buying power from somebody else, this is what our spend looks like. And if, you go out to a certain point in time, you say, well, here's where we're spending $10 billion a year on computer power. And if we design our own computer, it'll cost us $500 million to design our own computer architecture, but then that'll reduce our spend after that by, a factor of 3 or a factor of 5, or maybe you get faster machines. At the end of the day, because these clusters are so big, they become kind of a computational fabric. That is, nodes that are half as fast, if you have twice as many, that's roughly fungible. Like, you roughly get as much computation if your nodes. So the performance of individual nodes, like, you can do a trade-off between how fast your nodes are and how many of them you put into this machine. And it all just becomes compute. Like, how much money are you paying to get a certain amount of computation done to do part of this overall research and development task that you're doing? So at the end of this whole thing, it's just money. It's like, how much money do I need for a certain amount of computation? So I would guess that probably as much as anything, what would be driving Tesla's decision to develop Dojo, and what would be driving the considerations for what they want this machine to be, is, what do we think we're going to be spending on compute in 5 years, and what can we do today to make that number as reasonable as possible? Mm-hmm. Because, like, neural networks, this is a bottomless pit. Yeah. Like, you can throw infinite amounts of computation into this, and the more you have, the better your system is going to be.
It seems like, in recent maybe year or two, that there's been this shift where people are now pretty much in agreement that compute power with neural nets is really important, because the bigger your neural nets, with all this data, it just seems like the performance is getting better. I think it seems like OpenAI is kind of like pushing the envelope in terms of just like throwing, data and compute power to.
Well, they helped us understand that neural networks scale.
Yeah,
right? Because for a while you could legitimately ask the question whether you would get your money's worth if you had 10 times as much compute or 100 times as compute. And it seems like, from what OpenAI has done, and other, Google Brain, other people have done scaling studies now too. And it seems like the consensus is they scale, right? And so, you can just keep getting better performance by just, every domain has a limit. There's an information theoretic limit about how good you can perform in particular domains, right? But if you have an existence proof, like, human beings are bound to the same information theoretic limits, because it's an aspect of the problem and not the computation thing. So you can say, well, if a human can do it, eventually we can do it with a big enough computer, right? And so if humans can drive cars, eventually the scaling will get you there. And scaling, in a lot of ways, is the most straightforward way to get improved performance, right?
Yeah. With their latest cluster that we just talked about, how long do you think that it takes to train their neural net models with that cluster? Is it like a week or so, you think? Or
so the examples that Karpathy had used in the past when he was talking about this stuff, he was talking about 1,000 GPUs. Like he had said, it took 72 70,000 GPU hours. So 3 days on 1,000 GPU cluster. Like he mentioned that example a couple of times. And so I'd been assuming that, they had about 1,000 GPU cluster, and this one is about a 6,000 GPU cluster. Right? Although these GPUs are a lot fancier. Like these GPUs are probably, they would be 2 or 3 times as capable as the best GPU that Tesla would have had access to 2 years ago. I think the first time Andre came out with this. So this machine, and it's probably like 10 times faster than the machine that they had before. So if they were training the same neural network that they were training 2 years ago, they would have reduced it from 3 days to 6 hours or 12 hours or something like that. It'd be 10x less time. So that's a pretty substantial improvement. But the flip side is now they're doing this, they've decided to take this extra computation and take on a harder task, which is let's do more of the training from video stuff, which is, it's a separate task, and you only have to do it once. Like every clip that you run through this system, you only run it through one time to generate this output, and then you can save that. It becomes part of your database. But whereas the neural network, they train that over and over and over again because they're constantly making new neural networks.
Got it. Tesla AI Day. I mean, Elon Musk just reiterated on Twitter that it might be end of July or so. I think it's kind of like overlapping the annual shareholder meeting dates. I don't know if they'll combine it, but if they hold a Tesla AI Day, and Elon also said it's mostly for recruiting. What do you think they'll share? I mean, it seems like the latest Karpathy talk kind of was I don't want to say a preview, but it felt like kind of almost a preview of AI Day, giving kind of a progress update. But what else do you think Tesla can share on Tesla AI Day?
If it's so Andre's talk from yesterday or the day before, it clearly wasn't directed at the Tesla community or the competition or other OEMs. And it wasn't intended to inform the world about what Tesla is doing. It's bait because they're trying to sound cool and interesting to people who have something to contribute to this effort, right? He starts off his talk explaining super basic things that anybody who owns a Tesla probably knows about Tesla, right? Because a lot of these people don't. A lot of the people that they would like to hire, they're not Tesla people. They're machine learning people, and they might be machine learning people with a narrow focus, or so they might not have much familiarity at all with a lot of the stuff that we kind of take for granted and which seems pretty basic to us. But in order to attract them, especially the people that Tesla wants, they need to make the case to those people that Tesla's working on stuff that you can't work on other places, that it's meaningful, right? That they will succeed. Ultimately it will be rewarding. And I think, if AI Day is for recruiting, you're going to see more of that kind of stuff. They'll be trying to make the case to people who are coming to work at Tesla that they'll be able to achieve their career objectives and make a meaningful contribution and learn a lot, right? So to the extent that things get revealed, it will be revealed to that audience for the purpose of making them want to go work there, which is great for me, right? Because they'll talk about stuff that I think is really interesting. But if AI Day is for recruiting ML specialists, I think that it's probably going to be a lot less entertaining to the Tesla community than Battery Day was.
Got it. Interesting.
But we'll see. It's a great opportunity for the company to just generally be a booster about their own, accomplishments and future prospects.
Yeah. What's interesting is if this current cluster, even pre-Dojo, is like, let's say $150 million supercomputer, and they're planning for the next gen. They're continuing to push the envelope because they know how much compute power they're going to need in the future. And let's say next year it's like over $1 billion or whatever, and it's just like continues to grow. It seems like who else is even in the same ballpark as this? Like, who has even the data and to process, that requires this type of, supercomputing power? It seems like everyone else is operating on a completely different scale. What are your thoughts with that?
I think it's Elon's crack about that number 2 needing a telescope. It's going to be a really big telescope. Yeah, it's hard to figure out what I think for a viable competitor to come up at this point in this space for Tesla, either enough time has to pass that advances in the field obsolete a lot of work that Tesla has done, and that will happen. Right. I don't know how long it's going to take, but Tesla has to keep moving really fast because everything that they've done up to now is just going to get easier and easier to duplicate. Or you're going to have some very, a sovereign government or some other deep pocketed entity step into the space and decide that that it's a national priority for them to not lose this war, not lose this competition for the capabilities that Tesla's bringing online. And I could also see that happening. I would say that's probably the more likely of the two, at least regionally.
Yeah, it's definitely fascinating stuff. Across our this talk today, this marathon series, we have the whole fleet advantage, the data advantage. You've got the whole full stack advantage. Now you've got this supercompute advantage, and it seems like a lot of this stuff is intertwined. It all feeds off of each other. For example, if you don't have the data, if you don't have the fleet, then how can you make use of these 3D modeling? For for depth predictions, and how do you use auto labeling? It doesn't really matter much, if you don't have the material to work with, right? And it just seems like it all feeds together, and it doesn't seem like it's a simple thing just to snap your finger and a OEM or competitor just to replicate the entire everything.
Building, anybody could buy one of these machines that Tesla is showing here, right? That's just money. Building them, not super hard. It is some specialized engineering, but I don't think it's super hard to get the kind of people who can do this. I could be wrong about that. Obviously, Tesla's using it for recruiting, so I guess it can't be trivial. It sounds like Andre said they've still only got 20 people training neural networks at Tesla on this last thing, which is, I think that's actually a smaller number than he mentioned 18 months ago. Although he might have been talking about different categories.
Yeah. I want to ask about this kind of the ending of Andre Karpathy's talk. He talks about how they're doubling down on vision. They think that they can solve full self-driving with vision alone, and it seems controversial in the sense that some people are claiming that Tesla will need LiDAR, et cetera. One analyst, I think Pierre Ferragu on Twitter, was saying in 4 years he's betting that Tesla will add LiDAR, to improve the system.
I wonder how much he'll bet me. I should ask him.
Yeah, maybe we should have a Twitter bet. But yeah, the gist of what tracking full self-driving, the progress over many months and many conversations with you as well, it just seems like that's not the direction that everything is headed. Adding these other sensors, or it just seems like vision is enough. And it's just I guess the question is that it seems pretty evident to me that Tesla doesn't need LiDAR or radar or any other sensor. Vision will do it. But one question mark is that, do you think in the far future, 5 years down the road, that they've got a great system working, but they think that adding an additional sensor will actually improve safety? Or do you think that just adds more complexity and it's just probably not worth it, and it's going to be vision for the next at least 10, 15 years or something?
Trying to think of a sensor. So a scenario where you would want to add a sensor would be where you have this really high value thing, and it doesn't matter if the integration is really good, right? In other words, sensor fusion is a small concern compared to the potential value you get from this sensor. And this sensor does something that you simply cannot reasonably do with vision. And like for the driving task in particular, that's kind of hard to get to because all of the infrastructure of the world and all our everything is designed to drive with vision, right? There are no people driving with lidars or, there's no infrastructure out there that assumes or really benefits from that kind of stuff today. You can imagine like, some kind of industrial scenario where, you had to drive in these incredibly low visibility environments constantly, right? Or, like if you're building a robot whose job was to like drive a snowcat across or, Antarctica in the middle of winter, right? In the middle of the night, I can imagine there are scenarios where maybe vision, really needs to be augmented by something else if you're going to make it work. But whether, Lidar, there's a history behind Lidar, why Lidar ended up being the alternative to vision. And that is to some extent path dependent. It's not at all clear to me that going forward in the future, that if you were going to pick an alternative, it would be like, why not thermal infrared? Like thermal infrared is an amazing complement. It's much higher bandwidth than Lidar is. If the main thing that Lidar gives you is depth, and vision can give you depth, well, the big thing that you're getting out of Lidar is no longer something that you can't get for cheap. Is there some other sensor that would give you some other thing that neither Lidar, that vision, if Lidar can't give you anything vision can't give you, what could give you something vision can't get you? And like seeing in the dark or seeing when you must always drive in occluded situations. But thermal infrared, deep infrared is much better at dealing with occlusions than regular vision is. And it would fit on a neural network stack, and so you could go with that. So there could be sensors, but I don't think. I think that once vision gets to a point that, which I think it, Tesla is demonstrating the core capabilities for all of the real core all of the central things that vision really needs to be able to do to drive the task. Then you have to expand the driving task beyond what humans do. Got it. Before it's likely that an alternate sensor is going to become a candidate for what's going on. Yeah, Tesla's not going to put a LiDAR on the car.
Yeah, I mean, it seems like once Tesla,
they're not even going to put radar back on the car.
Yeah. I mean, it seems like once they solve this kind of 3D scene, and all the depth and velocity of all the objects, it seems like I don't know what's the point of LiDAR or radar after that. It just seems like they've developed vision to the point where it's like radar and LiDAR doesn't seem like adds much value.
One really interesting takeaways for me from this, I had always understood that sensor fusion was not easy. It hadn't seriously occurred to me that sensor fusion might be hard enough that you would never want to do it. Right? Like if you have a system where you have these rare edge case failure modes that are hard to test for and hard to gather data on, and it's possible, and it hadn't occurred to me until recently that this might be the case, but it's possible that fundamentally sensor fusion is a bad idea, right? That in all cases they're likely to occur in the real world, having a single sensor, which is more than capable and really doubling down, doing a really good job with that one sensor, instead of having two different sensors, which you choose because you think they're complementary, but the fact that they're complementary also means their failure modes are highly discorrelated, right? And if your litmus test is edge cases, it might be the case that your edge case failure modes are also going to be highly decorrelated. And it's just going to be monstrously difficult to get both of those two sensors to cooperate in the edge cases. Like if the edge cases are what you're worried about, it's different if the two sensors are both, if the supplemental sensor is highly useful most of the time in 99% of the driving. But the case with radar and vision right now was always that radar is a supplemental sensor. We use it in these rare cases where vision doesn't work. But the thing is, some fraction of those, the radar also fails, and now you're really hosed, right? Like that might be the general case. And if that's the case, then, like sensor fusion is just going to go away. People are going to pick the single sensor that encompasses the needs of the application, and they're going to go really deep on that. And that's a very interesting generalization a generalization that you might be able to take away from what. I think it was surprising to Tesla that they came to a point where they're like, getting rid of the sensor is a win. Like, it's not a win because we're saving some money, and it's not a win because we're saving a couple people's time. It's a win because for the same amount of effort, the system is better without the sensor, right? In that case, it's a win.
Yeah.
It seems super counterintuitive. I wouldn't be surprised if it was so counterintuitive to Tesla that it took them a really long time to get this point. Yeah. And I think it's so counterintuitive that even if it's true, most of the world isn't going to come around to believing it for a long time. Yeah. But if it's one of those things, if it's true and most of the world doesn't believe it's true, it's another giant advantage for the people who get it, right?
Exactly. Yeah, it just, the whole idea of it's a trap, it's like, that comes to mind. It's like Lidar is a trap. It's like, it just tricks you into like thinking you need it or radar, but ultimately it like destroys, your ability to get somewhere. It'll be
really interesting if that's how things work. And it could, I'm super surprised at the results that once again, I've said this a couple of times. I don't think Andre is cherry picking this data, but I don't know that it's not cherry picked. I mean, a lot of times when you do a presentation, you trot out the slide, which is the most interesting one to have your talk about, right? So I don't know if the difference between what they get with what I was calling pseudo lidar and what they get from their legacy stack is, like, if that's representative in the world. But if it's representative in the world, it might be indicating that indeed sensor fusion is a bad idea. Like, if your sensors are sufficiently disparate and their failure modes are sufficiently disparate, that sensor fusion will always be more trouble than it's worth. Mm-hmm. It's possible. I don't know. Yeah, it's interesting to contemplate, largely because, look at the Christmas trees that Waymo's driving around, right? Or Cruise, right? Those guys clearly believe more sensors is better, right? More sensors, more different kinds of sensors. And the thing is, if it really is a trap, boy, those guys are in for a world of pain, right?
Yeah, definitely.
Who knows?
Yeah, who knows? Anyways, wanted to thank you, James, for taking us through all of this stuff. Super helpful for me personally to just take a look at all these different angles, and I'm sure it's helpful to all those listening. So definitely want to reach out with appreciation and thanks. And definitely. And we'll go ahead and end here, but I'll go ahead and link to James's Twitter profile. Go ahead, follow James on Twitter. And I'll also link to his playlist on my channel. It's James Douma on AI. We have a bunch of videos kind of detailing a lot of these topics that we've done in previous episodes. All right, we'll see you guys later. Bye.